Okay, so since we're just now introducing, cosine and sine, let's try and see if we can visualize what a cosine and sine function looks like. And we can do that with very little effort with the information that we've already learned. So we're going to look at graphs of cosine theta and sine theta. So first, let's look at cosine theta values on the unit circle. So you can see we've got the unit circle here. And remember, the cosine values are the x values at the terminal side of every angle of interest. Okay, so all the x values going all the way around. And the sine values on the unit circle is going to be all of the y values of the intersection of the terminal side with the circumference of the unit circle. So to make things simple, what I've done is I've taken a few of the angles where things are going to graph nicely, okay? And so if we look at cosine and we look at 0 degrees, okay, which is going to be here, cosine theta, cosine of 0 degrees is 1. Let me erase all these here. There we go. And if we look at 60 degrees, so here is 60 degrees, the cosine of 60 degrees is 1/2. And if we look at 90 degrees, the cosine at 90 is 0. If we look at 120 degrees, the cosine of 120 is -1/2, and so on. So let's make a graph of theta on the x-axis and cosine theta on the y-axis. All right, so let me use a color here. So I'll just use dark blue. Okay, so at 0 degrees, cosine theta is 1. At 60 degrees, cosine theta is +1/2. At 90 degrees, cosine theta is 0. At 120 degrees, cosine theta is -1/2. At 180 degrees, cosine theta is -1. At 240 degrees, cosine theta is -1/2. 270, it's 0. At 300, the cosine of 300 degrees is +1/2. And then at 360 degrees, which is one full rotation around the unit circle, we have +1. So if we kind of connect these dots, what you get isn't a straight line. What you get is a curve that looks like that. And so what we've graphed here is we've graphed one unit circle rotation. And that equals what we call one period. So one period in a trig function is one unit circle rotation from 0 degrees up to 360 degrees. And when we go to graph these a little more regularly, this constitutes a plot box. So this plot box are the bounds of our cosine trig function, as well as representing one period in the trig function. All right, let's do the same thing here with sine. So I've just taken the sine values and I've put them in the table down here, and I've chosen the simpler values, okay, because that's all we need to kind of get the idea. So at 0 degrees, sine of 0 is 0. At 30 degrees, sine of 30 is 1/2. And then at 90 degrees, sine of 90 is 1. And then at 150 degrees, the sine of 150 is 1/2. At 180 degrees, the sine of 180 is 0. At 210 degrees, the sine of 210 is negative 1/2. At 270, the sine of 270 is negative 1. 330, so the sine of 330 is negative 1/2. And then the sine of 360 degrees is back to 0. So we've done one period of a sine function, and you can see this is what it looks like. Just like that. We can draw a plot box around it here. Okay, and this plot box represents one unit circle rotation or one period of this trig function. Now, this trig function just keeps going. Okay, sine keeps going that way, sine keeps going that way, cosine keeps going, and cosine keeps going. So these functions just continue on into positive and negative infinity forever, which is too much to graph. So that's why we graph just one period of it, and that's enough. Okay, let's look at some of these auxiliary questions that we have here. Okay, so what is the domain for both cosine and sine? Or why is the domain for cosine and sine both infinite? So remember that domain is all of the x values. And in this case, our x values are values of angles of interest. They're theta. And as I just mentioned, it can keep going with higher values of theta. And it can also keep going in a negative sense over to the left. So that's why the domain of cosine is from negative infinity to positive infinity. Okay. And now if we look at the range, what are the range of cosine theta values? Well, they go from positive 1 to negative 1. So that's the range. So from positive 1 to negative 1. And we've got brackets here to show that it includes those values. And you can see the domain and range is the same for sine. So why is the domain for both cosine and sine infinite? Is because cosine and sine go to positive infinity and negative infinity. And are cosine and sine relations functions? So they're functions if they pass the vertical line test. And you can see as we draw vertical lines through the function, it intersects the function in only one spot. And so the vertical line test is just the test that you do to see if a relation is a function. Okay, and the same will be true of the sine function as well. So yes, they are both functions because they pass the vertical line test. Now, if you wanted to, you could put in, you could graph 30 degrees and 60 degrees, right? 15 degrees below this one and 15 degrees above that one. These two marks up above, these are square root of 3 over 2 and square root of 2 over 2. That's those two values. So if you wanted to, you could plug those in, from what you find going around the circle. But I just wanted to pick a few values that would be the easiest to graph and more quickly see the picture that we're looking for. Okay, so I think that this is a good point to stop here. Let me know if you have any questions.